This is your Jagan sir. Welcome back to our YouTube channel, Jagan sir. And today we are going to discuss 10 class on kinematics. The topic is projectile motion on an inclined. And see, before we are going to discuss this concept, I would like to tell you a small concept. Projectile motion or an inclined plane. Right? See, the first point here is before this class we had all timing time of height, horizontal range, maximum height values by using this as x-axis and this is y-axis. This is y-axis. And object starts journey by making an angle and falling at somewhere else. But now the situation is different. The situation says that if object starts journey and inclined plane, let us assume making an angle theta naught, inclined plane making an angle theta naught, and here if the object starts its journey and falling at this point, how we can find maximum value for maximum range and range value and time of flight? How can we find those quantities if the condition is like this? And before we are going to discuss, we need to recall a small concept. As per the concept which we were covered so far, as we consider this as x-axis and this as y-axis. This is y-axis. Now what I am telling you is, for our convenience, we can consider this as capital x-axis, and this as capital y-axis. Right? Now, if it is theta naught range, obviously this is also theta naught. Right? And let us assume it is making an angle alpha. Initial velocity u is making an angle alpha. Right? And u will have two components. This becomes u cos alpha and this becomes u sin alpha. Right? And alpha is the angle made by projectile with respect to capital x-axis, and that's why we have two components of velocity. One is u cos alpha, other one is u sin alpha. Right? And here, first of all, how can we find time of flight? Find the time of flight. Finding time of flight. Then by using S by is equals to u by t plus half a by t square, and here on capital y axis. Here I am considering this is capital Y, this is capital X axis, this is normal Y axis, this is normal X axis. Right? So on capital Y axis I am going to solve S by is equals to u by t plus half a by t square. Right? Now here this is capital Y axis. Object starts its journey and falling at this point means displacement on capital Y axis is 0. Right? And initial velocity on capital Y axis is u sin alpha into t plus half acceleration on capital Y axis. See here, originally this is g value, but when we were resolving or when we were tilting this by an angle theta naught means this will get two components theta naught, that is this will be g cos theta naught and this will be g sin theta naught, and g cos theta naught is the acceleration on capital Y axis. See, this is capital Y axis and which is parallel. This g cos theta naught is parallel to Y axis. That's why I am considering this minus g cos theta naught on acceleration on capital Y axis, and this is acceleration on capital X axis. And remember, with respect to point of journey, that is, we consider this as origin, origin. From origin to upward direction positive, to downward direction negative, rightward direction positive, leftward direction negative. So can you see this will be minus and this will be minus. Clear? Then here acceleration on y-axis minus g cos theta naught into t speed. Now time of flight therefore t is equals to 2u sin alpha by g cos theta naught. Cos theta. Now this is what is time taken by the projectile on inclined plane to travel from this point to this point. Right? Now, next point, let us see, find the range value. Find the range value. And see here, range from here to here. How much will be the distance, that is Sx or range value? And obviously, this will be my capital y-axis and this will be my capital x-axis. Alright. Now, range on capital x-axis, range on capital x-axis. Now, by using Sx is equal to uxt plus half ax t square. Right? Then Sx is range and ux is, as I told you, this will be u cos alpha. So u cos alpha into time is equal to, we form it as 2u sin alpha by g cos theta. 2u sin alpha by g cos theta naught plus half acceleration on x-axis. Just now I discussed this one. This is acceleration on y-axis. This is acceleration on x-axis, which is equal to minus g sin theta naught, because this is theta and this one we have seen in the previous diagram very clearly. Then this will be minus g sin theta naught into 2u sin alpha by g cos theta naught whole square. Clear? Right. Now we can write it as range is equal to u square to u sin alpha cos alpha by g cos theta naught minus 4u square sin square alpha minus 4u square sin square alpha by g square cos square theta naught, and this is 1 by 2 minus right g 1 by 2. This is in the numerator. G sin theta naught. Now, G can cancel this 2. Now, range is equal to here I can take u square common, then this will be sin 2 alpha and for numerator and denominator and multiply with cos theta naught g cos square theta naught minus 2 u square sin theta naught sin square alpha by g cos square theta naught. Right? Now by using cos 2 alpha is equal to 1 minus 2 sin square alpha. So 2 sin square alpha becomes 1 minus cos 2 alpha. Right? So I can write range as here u square sin 2 alpha cos theta naught by g cos square theta naught minus 2 u square sin theta naught 1 minus cos 2 alpha by g cos square theta naught. Right? Now, next one, u square by g cos square theta naught sin 2 alpha cos theta naught. Right? U square by g cos theta, we took this common. Right? Now, right, do something from there. Okay. Right. This is 2 sin square alpha. So, u square sin theta naught. This will be 2 alpha. Right? Then minus u square g cos square theta naught to common sin theta naught plus cos 2 alpha sin theta naught. Right? Then this is u square by g cos square theta naught. This will be sin 2 alpha plus theta naught minus sin theta. Here, since sin of a is b is equal to sin a cos b plus cos a sin b. So here sin a cos b, cos a sin, and writing as sin a plus b, and minus sin theta naught minus sin theta naught. And this is what is the range value on the inflected. This is what is the range value of the inflected. Now, find the maximum range, maximum range. See here, for maximum value, you can note one point here. U is the initial velocity of the object, which is constant, and theta naught is the angle between inclined plane and horizontal, which is also constant. Then here only one term which we can modify is alpha value. So I am considering it as equal to 1, which is maximum value of this cycle. So by using this one, can I write 2 alpha plus theta naught is equal to sin naught is equal to sin pi by 2. That means 2 alpha plus theta naught is equal to pi by 2. Then 2 alpha is equal to pi by 2 minus theta naught. Then alpha is equal to pi by 4 minus theta naught by 2. Let it is equation number 2. Now, let it is equation number 1. Then it is equation number 1. Then it is equation number 2. Now, substitute equation number 2 in 1. Then R max value we will get as u square by g cos square theta naught. That u square g cos square theta naught sin of 2 alpha value is pi by 4 minus theta naught by 2 plus theta naught minus sin theta minus sin theta. Right? Then R max value becomes u square g cos square theta naught sin of pi by 2 minus theta naught plus theta naught minus sin theta. Here I am multiplying 2 with this one. Now R max is equal to u square by g cos square theta naught sin, these to be taken cancelled, pi by 2 minus sin theta naught minus sin theta naught. Then this will be R max is equal to u square g cos square theta naught 1 minus sin theta naught. And now I can remodify it as 1 minus sin theta naught by 1 minus sin square theta naught. So by using sin square theta plus cos square theta is equal to 1, I can write like this, and this will be u square 1 minus sin theta naught by g of 1 minus sin theta naught 1 plus sin theta naught. Then these two will get cancelled, and ultimately we will get r max value is equal to u square by g 1 plus sin theta. This is what is the maximum range of the inclined plane. This is what is the maximum range of the inclined plane. Right? Now, next one is velocity. Velocity at the point of hitting. At the point of hitting. That means the case is here. The case is here. Object starts its journey from this point, and suppose it is falling like this. This is the final velocity. Obviously, this final velocity, let us assume taking an angle theta here. Right? Now, this will be v cos theta. This will be v sin theta, and obviously, object starts from this position. This will be capital y axis, and this will be capital x axis. Capital x axis. Now, see here, if it is starting with the initial velocity q, and this will be taking an angle alpha v, and it is theta naught, u cos alpha, u sin alpha, and this is g. This becomes g cos theta naught. This will be g sin theta naught, and negative sign. The velocity at the point B, let us assume it is point A. Velocity at point B is equal to v cos theta I minus v sin theta j. V sin theta j. And here I am representing negative because velocity is representing the downward direction of the inclined plane. Right? Now, find the v cos theta. V cos theta. Right? Now, by using Vx is equal to ux plus ax, and all are on the capital x axis. Now, v cos theta is equal to u cos alpha according to this one. This is ux instead of the x axis. U cos alpha minus acceleration on x axis is minus g sin theta naught. Minus g sin theta naught into time of flight is 2u sin theta per g cos theta naught. Right, 2u sin alpha. Actually, according to our situation, time of flight is here. Two is sin alpha by g cos theta. Right, correct. Right, 2 is sin alpha by g cos theta naught, and this will be 2 cos alpha minus 2 g get cancel 2u sin alpha sin theta naught by cos theta naught, or u cos alpha minus 2u sin alpha tan theta naught. This is what is v cos theta. Right? Now, similarly, finding v sin theta by using v on capital Y axis is equal to integral of capital Y axis a by t. Then v by is equal to v sin theta minus of, then this is u sin alpha minus g cos theta naught, and time is equal to 2u sin alpha by g cos theta naught. Right? Right. Here. Now, then these will be cancelled. Minus b sin theta is equal to u sin alpha minus 2u sin alpha, then minus b sin beta is equal to minus u sin alpha, then b sin beta is equal to u sin alpha. And these are the b sin alpha, b cos beta, and initial final velocity on x-axis, final velocity on y-axis, and we can substitute the equation to get the final velocity of the object at the point of p, at the point of k. Here, I hope you are getting very clear thing. Now, it is very difficult question. This is difficult topic actually, but still I am trying my very best to give you the perfect subject. If you will projected in the equation. Now, the next concept is if the projectile, but projected, the projectile projected down the inclined plane, down the inclined plane. That means, see here, it is one of the logical and important and conceptual topic. Probably you will get confusing with first class, but I am trying my very best to avoid the confusion because I am discussing each and every single concept which makes you feel more strong and more comfortable in the understanding. Right? Now, see here, the condition is if object starts journey and falling at this location, how the h value will be taken. This is what the condition is. And let us assume, as we discussed, the object's initial location is making an angle alpha with respect to the positive x-axis. So I am considering it alpha only, right? That means, anything which is equal to 180 minus alpha, which is equal to alpha dash, right? Now, we by using range is equal to what is range formula? U square by g cos square theta naught sin 2 alpha plus theta naught minus cos theta naught. Right, let us clarify this. Right. U square by g cos square theta naught sin 2 alpha plus theta naught minus sin theta naught. This is sin theta. Here we will get this point. Right. Now, as the projectile is, see very carefully, as projectile is moving in the downward direction, I have to keep it as negative. Then here alpha is equal to 180 minus alpha dash. I can also write like this. Right? That is minus r u square g cos square theta naught sin of 2 180 minus alpha dash plus theta naught minus sin theta naught. Right? Then minus r u square g cos square theta naught sin 360 minus 2 alpha dash plus theta naught minus sin theta naught. Then minus r u square g cos square theta naught sin 360 minus 2 alpha dash minus theta naught minus sin theta naught minus r u square g cos square theta naught this will be minus 2 alpha dash minus theta naught minus sin theta naught, and therefore we can cancel the negative sign. Therefore, the h value will use is by g cos theta naught sin 2 alpha dash minus theta naught plus sin theta naught. Here, and by using the same procedure which we were solving, we can find R max value as used this by G 1 minus sin theta naught, where we got 1 plus sin theta naught R max value as. Right, 1 plus sin theta naught, but for reversal projectile, you will get only negative sign. Used by G 1 minus sin theta naught. And therefore, you just try to solve yourself this one. And if you have any doubts or if you have any problem in solving that one, let me know. I will definitely try to explain you how to solve that one in any other field. Here, right now, next one is see here. Let us go through with some numericals. Let us go through with some important logical and critical numericals. It is most important for understanding concept is first point most important, and after that, application of concept over the given situational conditions or given questions is one of the most important tasks. That's what I make you to be more comfortable by using these numericals. So try to practice these numericals before you are going to practice your regular material. That gives you a lot of knowledge in understanding the subject, so you can easily go through with your materials in a short interval of time. Now the question is, at what angle should a ball be projected up an inclined plane with a velocity v naught, so that it may hit the inclined normally? That means, suppose if an object is present here it is falling like this. The angle of the inclined plane in the object is alpha. And here they are asking us to find theta. Here they are asking us to find theta at what angle should be ball be projected up an inclined plane with a velocity v naught. Right? Now this v naught means obviously this will be v naught cos theta. This will be v naught sin theta. Clear? Now the second point here is the most important point is here let us assume a small concept before we are going to solve this question. The concept says here, if an object is exactly falling perpendicular to the surface, that means it should possess a velocity on the y-axis. Obviously, it should possess a velocity on the y-axis, but its velocity on the x-axis becomes 0 because it is falling perpendicular. So if the velocity at this point on the x-axis remains g. Clear? So we have to use that concept now and try to solve this question now. That means on the projectile, on the inclined plane, suppose it is making an angle 90 degrees. It is making an angle 90 degrees. Velocity, final velocity on the x-axis becomes 0 by using this concept which we were covered just now. Right? Now, by using Vx is equal to Ux plus Axt. Now, Vx is 0, Ux is equal to V naught cos theta naught, and Ax again G cos alpha, because it is given as alpha not theta naught, which we were covered in the concept, and this will be G sin alpha, and obviously they are represented in the opposite direction to the direction of motion. So I will have to keep them as negative sign. Now, the minus G sin alpha into T. Now, this becomes T is equal to V naught cos alpha cos theta naught by G sin alpha. That will be equation 1. Now, by using time of flight of projectile motion on inclined plane Like we know T is equal to 2u sin theta by g cos alpha. This is what actually we have seen in the concept. But remember, at the place of theta, there might be alpha is present. At the place of alpha, there might be theta not is present. So you have to keep this in your mind. Don't get confused here. Right? Now, let it be equation number 1, let it be equation number 2. Now, by equating, see, as a concept, we are getting kind of like a 2u sin theta not by g cos alpha. And by the equation, even according to the question, we got time value as v naught cos theta not by g sin alpha. Now, we are going to equate these two equations for finding the required angle value which they are asking in the question. Right? By equating 1 and 2, v naught cos theta naught by g sin alpha is equal to 2 initial velocity, so v naught, 2v naught sin theta naught by g cos alpha. Right? Now, v naught get cancelled. Now, this will be cot theta naught is equal to 2 tan alpha, and obviously they are asking us to find theta naught. So, theta naught is equal to cot inverse of 2 tan alpha. This is what is the equation. Okay, this is what is the equation like this. Now, let us go to the second problem. The ball is drawn from a height edge above a point on an inclined plane with an angle of inclination theta. That means, let us assume ball is falling like this, and this is the perpendicular, this is perpendicular. The ball is an elastic collision with the surface and rebounds off the plane. After collision, elastic collision, it is rebounds like this. The finally theta becomes same here because it is an elastic collision. Angle of distance is of angle of reflection. So this is angle of distance, angle of reflection with respect to normal. Right? Then, right, this is theta given. So let us assume this as alpha, this as alpha. Determine the distance from the point of first impact to the point where the ball hits the second time. Right? Now, the ball hits here and moving with certain amount of velocity too, and given this as h, and they are asking us to find what is the range value. What is the range value? Now, see here, velocity at the point of p, let us assume velocity before hitting point P, before hitting point P, its velocity value becomes, by using v square minus u square is equal to 2as on the y-axis, So, v square minus drop, so initial velocity is here u is equal to 0, 2 minus g minus h. So, V 2 minus G minus H, right? Small h. Then V is equal to 2GH. Now, this velocity acts as point of initial velocity for projectile motion, right? Now, therefore, we consider V naught is equal to under root of 2GH, right? And they are asking us to find range value, and range value is used by, let us see what was the range value. I will the formula is too big to remember. Range value used by like G cos by theta naught. Right. Right. Okay. U square by G cos square theta naught sin 2 alpha dash minus theta naught plus sin theta naught. Right? Now, regarding the question, this is alpha means this is 180 minus alpha, 180 minus alpha. Now, this becomes alpha dash. So, R is equal to U square G cos square theta naught sin 2 of 180 minus alpha minus theta naught plus sin theta naught. Then R is equal to U square G cos square theta naught sin 360 minus 2 alpha plus theta naught plus sin theta naught. Then R is equal to U square G cos square theta naught sin 2 alpha plus theta naught plus sin theta. Therefore, the equation is equal to U square by G cos square theta naught sin theta naught minus sin of 2 alpha plus theta naught. This is what is the equation. I hope you enjoyed the class with this written questions, and you will the first time you will practice these questions before you are going to practice your exam material. And the next point is remember conceptual understanding is most important for this type of technical concept. And still I try my best to give you 100% conceptual knowledge along with the numericals. And for daily practice sheets and weekend examination papers, you can follow us in our Telegram channel. This is Jagan sir. And take care. Bye bye.